Hello everyone. We are excited to present our project titled Stock Market Price Prediction, which we completed as part of our academic work at KJ Somaya School of Engineering. The team includes Ved Dhate, Shubham Chaurasia, Mayur Dumbre, Hriday Gandhi, and Farzan Irani. Our focus is on applying deep learning, specifically LSTM, to predict future stock prices. Now, the second slide will explain the problem definition. The problem we are addressing is how to accurately forecast stock prices in a supervised learning setup. We aim to design and implement a complete pipeline where historical data is processed, modeled, and used for future prediction. Specifically, we pre-process historical stock into sequences, train an LSTM model to minimize error and maximize accuracy, and then evaluate the model using standard regression metrics like RMSE, MAE, and R square. Once the model is trained and validated, we use it to forecast future prices in a rolling window fashion, allowing the model to adaptively predict the new few days based on prior patterns. So the next slide will be explained by Shubham Chaurasia.
Objectives of work. Our objectives are well defined. Firstly, we built a robust supervised learning framework using LSTM. Then we transformed raw data into meaningful sequences using windowing techniques. Once the data was prepared, we trained our model while carefully tuning hyperparameters like epochs and batch size to reduce error. After training, we evaluated the model using key metrics that provide insight into performance. Finally, we used the trained model to stimulate future predictions by repeatedly feeding the last known data back into the model. This helped us visualize how well the model could predict not just a single next day price but a sequence of future prices. Next. Datasets used. Our stock data comes directly from Yahoo Finance, accessed using the Y Finance API. The beauty of this setup is its flexibility. Users can enter any valid stock picker like AAPL or GOOG and instantly retrieve historical data. We collected daily level data from January 1, 2020 up to present. Although the data contains various features like open, high, low, and volume, we choose to focus exclusively on the close price. This decision reduces model's complexity while retaining the most meaningful indicator of stock movement. The data is then split. 80% is used to train the model, while the remaining 20% is reserved for testing on unseen data. The image shown on this slide illustrates a sample of the stock data emphasizing the close price column, which we use for modeling.
Hi guys, I'm Hriday. So let's dive deeper into tools, libraries, and the API used. Our entire implementation is built in Python, which offers a rich ecosystem for machine learning and data science. We used Yahoo Finance to gather data and NumPy and Pandas for cleaning and manipulation. To scale the data and calculate evaluation metrics, we relied on scikit-learn. The LSTM model was developed using TensorFlow and Keras, which offer high-level APIs for deep learning. For visualizing the results and trends, we used Matplotlib. Finally, we built an interactive front-end using Streamlit, a Python-based web app framework that lets user enter stock tickers, train models, and view forecasted results. So on to the next slide. So let's see the implementation, aka the architecture. Before diving into the steps, let's look at the overall architecture of our system. The process starts with user input, which configures the data collection and model training parameters. Once the data is fetched and pre-processed, it's fed into a stacked LSTM model. After training, the model makes predictions, which are displayed visually. So the diagram outlines this complete flow, starting from raw data and ending with prediction visualization and which is downloaded via Streamlit.
So let's move on to the implementation part, the first thing which we talk about is the user input and the data collection part. User input, the users input the stock ticker, forecast the horizon, and training parameters like batch size and epochs. We use the Y Finance API to fetch daily stock data from January 2020 onwards. focusing only on the close price for simplicity. Let's move to the next part where we talk about the pre-processing and the model training. Here we talk about the close prices that are scaled between 0 and 1 using min-max scaler. A 100-day sliding window creates input sequences. We either load a pre-trained model for or build a new three-layer LSTM, that is long short-term memory with dropout and a dense output. The model is compiled with Adam Optimizer and MSE, that is mean square error loss. Let's move to the next part where we talk about the prediction on the test set. So as you can see that we tested the model by predicting on unseen test data using the final segment of training input. Predicted prices are inverse transformed and plotted alongside the actual values, showing the strong alignment. Here we can see that red and green lines, they are the track predicted versus the actual prices. Let's move to the next slide where we talk about future forecasting and evaluation metrics. Here we talk about we take the 100 last 100 data points and we predict the predict data for 1 day ahead. We then recursively feed this new value back into the input window and repeating this process for as many as days the user has requested. This method gives us a full future trend line, which we visualize in the final charts. To assess how well our model performed, we use three metrics, that is RMSE, root mean square error. So our RMSE score was 8.18, indicating a moderate average error magnitude. Talking about the mean absolute error, that is MAE, at 6.66 score, this tells us that the average error per prediction is quite low. Talking about the R square score, with a score of 0.65, the model explains 65% of the variance in the stock prices, which is a respectable figure given the volatility in the financial data. The accompanying bar chart visualizes these metrics, making it easier to understand the model's strengths and where improvements could be made in future. Now, Ved will show the implementation part to you. Over to you, Ved.
So I'll be showing how we have actually done the implementation. So over here, as you can see, is our Python code first. These are all the necessary imports, LSTM models, dense LSTM and dropout, which are the layers used in the LSTM model, Adam optimizers, min-max scalars, and our mean square error formulas. Then the flow that goes through the code is we first fetch the stock data, we pre-process the data over here, then we build the LSTM model, which has got 50 layers and dropouts of 0.2 and one dense layer as well. The model is compiled via an Adam optimizer, and we have a learning rate of 0.001, which reduces the loss. Then the next thing that we do is we plot the moving averages as well as we plot the predictions, and the rest of the code is for the downloading these predictions. So I'll show you the final output. So over here, I have loaded a pre-trained model of the Google stock. And over here, as you can see, we have trained it for 20 epochs with a batch size of 32. We have predicted it for future 30 days. And so this is the stock data. It consists of the close values, high, low, and open values, as well as the volume. And it has started from 2020 of the January. And we have taken it till the present date. So over here, as you can see, we have our model evaluation results. The root mean square error is 8.18. The MAE is 6.65 and the R square score is 0.62. These are all very respectable error averages. Next, we come to moving averages. Over here, as you can see, these are different moving averages. Moving average of 50, which is the orange line, average of 100, which is the green line, average of red, which is the moving average 200. Over here, we can see that the moving average 50 is the closest resemblance to our stock data. Next, we come to the predicted versus the actual data. So over here, as you can see, the blue is our actual price data and the yellow dotted line is the predicted price. So it follows the trend quite properly. There are a few gaps, but it realizes the trends and patterns and it follows them completely. The next is the future 30-day forecast, which is the values for the upcoming days. This is recursively taken from the previous predicted values, put into an LSTM model, and forecasted for the next 30 days. And below, you can download all of these predictions in a CSV files. So now I'll be talking about our results analysis. Our model showed very promising results. First, we observed that the predicted prices followed actual prices very closely, especially during steady trends. Second, the model performed well on unseen data, indicating good generalization. And third, the prediction line was smoother than the actual, filtering out market noise and highlighting genuine trends. So together, these results show that LSTM can offer a meaningful edge in short-term price forecasting. These are some of the references that we have taken. Our work is grounded in a number of academic and technical sources, and we referenced recent IEEE conference papers that explore LSTM in the context of stock market price prediction. So thank you for your time and attention. We hope this presentation gave you a clear picture of how deep learning, particularly LSTM models, work and can be applied to real-world forecasting problems such as the stock price prediction. Thank you.